Okay.
Aloha and welcome to another exciting edition of Physics 251 Lab. Today we're going to be doing the inclined plane. Here's our inclined plane. We're using these little carts on the inclined plane. They got wheels, so they're supposed to be nice and smooth to minimize the effects of friction. Right here, these guys are photo gates. And so when the cart goes through, it'll block the light, and essentially this guy will know when the cart has gone through. And we got two of them because what we're going to be measuring today is the delta t, the difference in time when it goes through this guy and this guy. Okay, so I'll do you a little trial run here. Okay. So over here, the only data we're showing, there's really just one of them, but they just haven't doubled, is 0.60 seconds. So it took 0.6 seconds to go from here to there. Okay, so that's the only data that we're going to be looking at today. Now, well, the first thing I'm going to make you guys do is I'm going to make you figure out the angle of this thing. Okay, I'm going to let you figure out how to do it. I'll give you a hint. Here's my hint. All right, so I want to talk a little bit about the theory here. And I've got it written down on the board. And so here's the free body diagram for an object on an inclined plane. Gravity down the plane goes like mg sine theta. Gravity into the plane goes like mg cosine theta. And the other force is the normal force. We'll assume there's no friction. And we'll see how good of an assumption that is. So if there's no friction, and we do the sum of the forces in the x direction, we get mg sine theta equals max. Therefore, the acceleration in the x direction, I need to remember, whenever we do the inclined plane, we make the x direction down the plane and the y direction out of the plane. So the motion is in the x direction. So once again, we get ax is g sine theta. So the question I want to start off with is, how long does it take an object starting from rest to roll a distance x? And what I want you guys to do, I want to have you guys repeat this. I want to find the time as a function of how far, gravity, and the angle. So the solution comes from, I call it equation number 1, right? X equals x naught plus bx naught t plus 1/2 ax t squared. Starts from rest, so vx naught is 0. If you're clever, you let x naught be equal to 0. And so we end up with the time is, if you solve for time in this equation, you get 2x over ax, the square root. If we substitute ax as g sine theta here, we get the time is 2x g sine theta. Okay. Now, but remember, if we go back to the experiment, take a look at that real quick. Remember, we're actually measuring a delta t of between two different spots. Okay, and so we really want to find the delta t. So suppose we set our first distance to be 40 centimeters. How long would it take to roll 40 centimeters, for example? How long would it take to roll 60 centimeters? And what would the difference between those two guys be? So I could use my result over here, and the delta t is the t2 minus t1. Okay, and I just put the x's in, so you have the x2 here and the x1 there, where x2 is 60 and x1 is 40. Don't put the numbers in, right? Always leave the numbers out till the end. Okay? And so the delta t, I can pull out the square root of 2 over g sine theta, and I get delta t is that term times the square root of x2 minus the square root of x1. Okay, so I'm gonna have you guys. I want you guys to solve for this like I did here. Okay, and then we're gonna actually set it up and do it. Okay, we're gonna set the first photo gate at 40 centimeters, the second photo gate at 60 centimeters, right? And we're gonna measure the delta t. We come over here and actually do it. So if you notice, I always start the cart at the 20 centimeter mark, and you guys will do that too. So 40 centimeters means this should be at the 60 if that's at the 20. That's 40, and that guy should be at 80. So maybe you have to come around here, and we're going to do this. Oh, isn't that exciting? And we get 0.64 seconds. You guys do that, and then you compare what you get to what you had calculated it to be. And I want you to do that, and I want you to tell me how they compare. Give me a % difference. Talk about why it may be different. Is it longer? Is it shorter? Well, does that make sense? How much longer? How much shorter? What % difference is it? And then finally ask the question, for the real delta t that we get, what would the AX have to be in order to make that happen? All right, and discuss that a little bit. Okay. I think that's it for the first part. We're also gonna have a contest for this one. I'll come back and explain the contest after. Cut.